Hello everyone, welcome back to my channel. I hope everyone is doing great. My name is Raviteja. Let's solve today's Leetcode problem 693, binary number with alternating bits. Given a positive integer, check whether it has alternating bits. Namely, if two adjacent bits will have different values. If you take 5, 5's binary representation is 101 and no two adjacent bits has same value. Okay. If you take 7, 7's binary representation is 111 and if you see the adjacent bits in this position are same, so this is not a valid number, so we will be returning false. Okay, so the idea is to check the alternate bits are same or not. If both are same, then we have to return false, or else if the entire number becomes 0, then we will be returning true. So what I will be doing is I will first take the last bit as my previous bit. Okay, and then I will left shift my number so that I will be my remaining number will be 10, and I will check the last bit if it is equal to my previous bit. The last bit if it is equal to my previous bit, then both the adjacent bits are having the same bit, so I will be returning false. If the last bit is not equal to my previous bit, then I will make this as my new previous bit. I will make 0 as my new previous bit. Okay, and then I will repeat this algorithm. So that is what I've done. I've initially taken the previous bit as the last bit of my number, and as long as my n is greater than 0, I will left shift my number and check the previous bit is equal to the current last bit or not. If it is equal, that means the two bits has the same value, then I will be returning false, and then my new previous bit will become the current last bit of the number, and then in that I will be returning true. If we submit this problem, all the test cases will be passed and it will be pretty efficient solution. As you can see, it has beaten 100% of solutions in the runtime. Okay, yeah, the previous approach which I mentioned has a time complexity of log n and space complexity of big O of 1, because if you see the number, we are left shifting all the numbers, we are left shifting the number one by one, so this loop will run for log n time, and the space complexity is big of 1 because we are just using some variables. Okay, you can actually do better in terms of time complexity. If you see mathematically, let's say I have a number n which has alternating bits. Okay, now if I left shift my number, then this is what its left shift will look like. Okay, now if I take XOR of these two numbers, then my resulting number will have all bits as said, because 1 and 0 XOR value is 1, 0 and 1 XOR value is also 1. Since all the bits are alternating, okay, my final result will also contain all bits as 1. Okay, now if we add 1 to it, then automatically I will get a number which is basically 2 power. Okay, so if you add 1 to it, then I will get 1 and followed by 4 zeros. Okay, now if I take and between these two numbers, okay, if I take and between these two numbers, okay, then my final value will be 0, because 1 and 0 is 0, 0 and 1 is also 0, right? So if I have an alternating number n, and if I perform x and this particular value, then my final answer, if it is equal to 0, it will be 0 if n contains alternating bit. If it is not equal to 0, that means n will not contain alternating bits. Okay, so I just define x as n XOR of n left shift by 1. Okay, and then my final result will be this. Okay, if x and x plus 1, if it is equal to 0, that means it's an alternating bit, or else it is not an alternating bit. Okay, if you submit this problem, all the test cases will be passed and it will be pretty efficient solution in terms of both time complexity as well as the space complexity. Okay, that's all about this problem. If you like the explanation, hit the like button, hit the subscribe button, and also share your valuable feedback in the comment section. Thank you.